Space, 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 space. Space, 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 space. If you want to know about space, you have to know about the planets. If you want to know about the planets, you have to listen to me right now.
Inside the sea of nothingness known as space, there lie small glimpses of familiarity, extrasolar planets. Planets that, outside of the fact that they are orbiting stars very far away, are quite similar to any of our neighboring planets or even our own.
Extrasolar planets can be quite large when compared to Earth, but in the scheme of the galaxy, they are barely noticeable. How then do astronomers detect such relatively tiny bodies that, unlike stars, do not emit their own light in the visible spectrum?
There are multiple methods, each with their own positive and negative traits. The Doppler method is one of the most used methods. When a planet orbits a star, the planet's pull on the star causes it to oscillate. While this movement is minute, it can be large enough to cause a slight change in the wavelength of the light hitting us from the star as it moves closer and farther, squashing and stretching the light, causing blue and red shifts. If we see a star getting regularly closer and further, we can tell that there is a planet orbiting it. We can even use this method to detect multiple planet systems, as multiple oscillations can be happening simultaneously. Unfortunately, this method is not without its drawbacks. The planets must be on a plane facing us to some degree in order for us to detect a difference in wavelength. If the star is being pulled in directions not towards or away from us, the change in wavelength will usually be too small to detect. This method can determine the mass of a planet, but not its radius. Further, large planets not dissimilar to Jupiter cause larger oscillations and are therefore easier to detect, meaning detecting the smaller planets like Earth is much more difficult using this method.
The second widely used method is known as the transit method. When the light of a star regularly diminishes in intensity, even slightly, we know that something, possibly a planet or a dead star, is getting in the way. Using highly sensitive light recording instruments, astronomers can observe the light from a star over a period of time and record the amounts of light nightly. From the data they collect, they can look for patterns hinting at an extrasolar planet. Not only is this method better at detecting multiple planet systems, using this photometric method can also determine the radius of a planet, but unlike the Doppler method, it cannot be used to find the mass of a planet.
For this method to work, unfortunately, the planets must be on a plane facing us. In fact, the parameters for this method to work are higher than the Doppler method, as the planets must, at some point in their orbit, be between us and their stars. Further, larger, closer planets are easier to detect, as they block more light, and thus we've detected mostly large planets with small orbits, known as hot Jupiters. Further, this method results in more false alarms than any other method due to the large amount of unaccounted for variables, including objects far from the observed star blocking some of its light.
All astronomy students know that the Earth does in fact emit light, just in a lower frequency than we can see. This is true with many extrasolar planets. Using this information, astronomers developed a third technique, known as direct imaging. Coronagraphs are used to block the light from a star, and observations are made of the surrounding space. Unlike the previous two methods, this method can detect a planet orbiting on a plane perpendicular to us.
However, this method is the most difficult to use. It has only resulted in 5% of our discoveries, as the observations must be outside of our atmosphere due to the minute differences in the light that must be detected. Further, stars that are too close to their stars cannot be detected, as well as smaller, less luminous planets. Of these three methods, we can only search so far. Approximately 100,000 light-years in any direction is now searchable, but in the scheme of things, we are barely able to look out our metaphorical front door.
Why do we look for planets orbiting around strange, faraway stars? For one, learning about the state of distant stars and their planets can give us a better understanding of our own. From observing a young system, we can determine how ours came to be. And from observing an older system, we can learn more about the eventual demise of our solar system as well. And on that note, while it may seem silly now, one day our planet will die. And this may come long after our species is gone, but there is a chance it will come far earlier. We may need a new home sooner than you'd think.
And while this may be far from any reasonable astronomer's mind as he scans the night sky, it is still a distinct possibility that we may discover planets that are not only inhabitable, but inhabited. And while philosophers and biologists can argue all they want, there's only one way to know for sure: to actually look out there and check.